everybody. Welcome. I'm Paul Saxman, and I lead the Android Devices and Media Developer Relations team. Dan Gelpin's going to be joining us for the later half of the talk, the third part of the talk. Dan really doesn't need any introduction besides just who he is to a room of Android developers. Today we're going to talk about building rich media experiences with Android. So what are these rich media experiences that I'm talking about? Media, being audio, video, playback, and recording, is used in almost all types of apps in Android with only a few exceptions. This means that the Android media APIs are some of the most widely used by developers and users outside of the core framework. So it's important to pay close attention to the media experience while building apps, because an inconsistent media experience can draw negative attention to your app. So we're going to break this talk into three parts. The first part is about media app fundamentals. I'm going to talk about 4 very important media APIs that you need to know about. There's a lot of important media APIs, but I'm just going to focus on 4 of the most important. Then I'm going to talk very briefly about bringing apps to the TV, because we have some updates since Google I/O that I want to talk about with Android TV. And the last part, which Dan will present on, is tapping into Pro Audio on Android. So there's a new API called Oboe that we released not too long ago in developer preview that we'd like the developers to kind of try out and get feedback on. So 4 very important media APIs. Those 4 important media APIs are MediaSession, AudioFocus, PictureInPicture, and wide aspect ratio screens. The last one, not exactly an API, but it's something that is very important for media apps to keep in mind. Again, these are only 4 of the most important APIs. So obviously, media player, whether it be the media player or XO player, also very important. But these 4 are very fundamental to building a really core experience on Android. So the very first one, MediaSession, allows media controls external to your app. MediaSession is very important to Android devices, such as TV and Wear, as it allows media playback on the phone to be controlled by these devices. So if the user starts media playback on their phone, they plug it into an Android Auto capable head unit. Those media controls that they get on the head unit will control the media session on the phone. The same is true with Android Wear. If you have an active media session on your phone, you can actually control that media session using your watch. On Android TV can actually provide controls for media being played in the background if you're playing music. It's also, the media session is fundamental to the Google Assistant on Android TV. So if the user wants to speak, play, or basically transport controls into the remote using the Assistant, those transport controls are passed to the app using the media session. MediaSession is also used across the Android system to provide users with the ability to control playback while an app isn't necessarily in the foreground. For example, it's used by the lock screen interface. So if there's an active media session, the lock screen interface will show media controls to allow the user to control that. It's also used by media style notifications. These are the notifications that allow control for media playback while it's in the background. Media button input. So media buttons are buttons that you typically see on Bluetooth headsets. Play, pause, forward and backwards. Those media button inputs are passed to your application via the MediaSession API. And also PictureInPicture uses the MediaSession. So if your application is shrunk down to a small window size in PictureInPicture mode, if you have a MediaSession, the user can actually get playback controls directly on the PictureInPicture window. So the design for apps playing media in the foreground is pretty simple. Fundamentally, they have an activity and some player. To add media session support, you first need to add a media session. You instantiate the media session. This tells the Android system that your app is or will be playing media. You can then add media session callbacks, which allow you to bind transport controls, play, pause, seek, and forward, sent to the media session to your player. And finally, you need to add a media controller, which is how you bind media controls in your app. So if you have a media button in your application, you bind that to the media session. So if the user presses pause in your application, you use the media controller to send that to the session. That session will update the media session callback, so you can actually adjust the playback there. But then all these other external interfaces that are using the media session will all be updated at the same time, since you use the media controller. So apps that allow audio playback in the background are quite similar in their use of MediaSession. However, they have a service service for background music playback. You move the media controller to your activity. So you only really need the media controller when you actually have an active interface. Otherwise, those interfaces, like the media notifications, the lock screen controls, are all done automatically using the MediaSession API. So setting up a MediaSession is pretty straightforward. Basically, you have to instantiate a MediaSession. Here I'm using MediaSession Compat, which is part of the V4 Media Compat library. So basically, it's supported across most Android devices. Then you set flags about what you want your MediaSession to handle. Here, the three options are transport controls. Again, this play, pause, stop, seek as well. The media buttons, so these media buttons from Bluetooth headsets, and also queue commands. Queue commands are for adding things to like a playlist, or removing things from a playlist, or moving between items in a playlist. And then you actually have to set your MediaSession of active. And this tells the system that this MediaSession is available to be interfaced with. The other part that I mentioned is that you have to listen for media controller input in your MediaSession. So basically, you set the callbacks, which is a class that you have to create yourself. The MediaSession callbacks are very straightforward. They basically have all the media controls that you'd expect, all the transport controls, the media button controls, and also the transport control interfaces. And basically, once your app receives these events, you just pass them on essentially to your media player. Using the media controller is likewise fairly straightforward. You instantiate a media controller. Again, use the media controller compat. And then you can use that media controller to actually fire media control events, or transport control, queuing, or media button events. If the MediaSession happens to be in another process, so let's say you have a background service that is running the MediaSession, but you want the media controls in your activity, you can actually get a token from the MediaSession in your service, pass that up to your activity, and then use that when you instantiate the media controller. MediaSession is a fairly complex API. What I've showed you here, really just scratching the surface, but this is really the fundamental thing is actually to add this playback control into your application. The other things that it supports, media metadata. I mean, you can push information about the media that's playing to the MediaSession. That will show up on the lock screen or show up in the notifications or on your watch or your auto head unit. Syncing playback state, media queues. This is playlists, so you can add playlists to the MediaSession, and this lets other applications that are providing interfaces into your app know about that. Media controller callbacks, media style notifications, a lot of different APIs built in there. Getting started with MediaSession, basically understanding what I told you today, plus all these other features. There's a lot of things you could do. So developers.android.com, we have a full section on building media apps, and this covers mostly the MediaSession APIs and related APIs. We also published recently 4-part articles. One of my coworkers, actually, Nazmul Idris, 4-part articles on understanding MediaSession. So this is really probably where you want to start, because this breaks down the APIs like I did here, but in a little bit more detail. And also, we have several GitHub samples, the media controller, media browser service, and the universal media player. These all show various aspects of using the MediaSession APIs as well. So if you're looking for code, this is a great place to start. The second API that I want to talk about is AudioFocus. This is sharing control of audio output. Any app can output audio at any time on Android. And outputting audio needs to be cooperative. Basically, the system doesn't necessarily mediate control of the speaker. And this is what the AudioFocus API is for. The AudioFocus API has been around in Android probably since the beginning, but it was updated with Android O. And I'll talk about the differences here. There are 3 steps to ensuring a great audio experience. The first step is before you play audio, ask for AudioFocus, and only play audio if the AudioFocus is granted. It's very important to if AudioFocus has been declined, to actually not start playback. If somebody else asks for AudioFocus, deal with the focus loss. So basically, be ready to hand off AudioFocus from your app at any time. And when you're done with AudioFocus, release it. This one tells all other applications that they can also, now they can actually take control and use the AutoFocus if they need it. So requesting AudioFocus, basically you need to get the audio manager from the system. This is partially new. So the audio attributes has been around since API level 21. But this is the first time with Android O that the audio attributes are used with AudioFocus. So the audio attributes basically tells the system why you want to play audio and what type of audio that you're playing. And this gives the system the ability to make decisions about AudioFocus without necessarily kind of bothering the applications. So for example, if you're playing music in the background, you request AudioFocus and you're playing music in the background, if the system needs to play a notification sound, for example, it will automatically duck the music playback and won't necessarily call into your application. And this API here is actually new, the AudioFocus Request. So basically, when you actually request AudioFocus, you now need one of these AudioFocus Request objects. You pass your audio attributes. You create your on AudioFocus change listener. This lets you respond to the AudioFocus changes. And then you actually request the AudioFocus by passing that to the audio manager. Grabbing this result is very important because the next step, like I mentioned, is you only play audio if focus is granted. So this result can take three different values. It is either failed, the system did not want to give you AudioFocus. This could be because the system is actually, has exclusive access to the audio at that time. An example of this might be a phone call if the user's actively in the phone call. The AudioFocus request could be granted, and at this point you can go ahead and play your audio. And the third state is the AudioFocus request is delayed. Again, this is if the system has exclusive hold of audio, but you can get audio gain later on. And this is actually, that audio gain is passed through to the AudioFocus change listener. So the AudioFocus change listener, again, is how you listen for other apps to request AudioFocus, or if you AudioFocus is handed back to your application, you'll get the AudioFocus gain through the AudioFocus change listener. And these are the four states. These have existed prior to Android O. So basically, you're either getting another app is asking for giving you the AudioFocus back. You're losing AudioFocus for an indeterminate amount of time, which means that you should probably clean up your audio, your media playback or media player. The AudioFocus loss could be transient, which basically means you pause playback, and then the last bit is that it can be transient, but you can duck, which means you can basically turn down the volume temporarily. And then the last part that I mentioned is releasing AudioFocus is very important because this is when you tell other apps that you're basically done using it and they can continue their audio playback if necessary. Again, a lot of great resources for getting started with AudioFocus. We have a whole guide in our developer docs on managing AudioFocus. Also very recently, the same author, Nazmul Idris, wrote a 3-part article on understanding AudioFocus. He breaks down these different use cases, and he also talks about the new APIs as well. And also we have several samples, both for testing and demonstrating how the AudioFocus should work in your applications. The third API I want to talk about is PictureInPicture. PictureInPicture allows your app to actually continue media playback even after your application has been paused. So you can see in the example here, the user is doing a video chat. When the user actually goes back to the home screen, the video chat window shrinks down, stays on top of the home screen, and also stays on top of other apps. This API is really important for media apps, especially video apps, because if the user is watching a movie, for example, and they want to go to basically check something in their calendar, they can continue playback without actually, or they can check their calendar without actually disturbing the playback. There's 3 steps essentially to supporting PictureInPicture. You have to declare PIP support in your activities. You have to switch to PIP mode as needed. And you have to hide non-essential UI while in PIP mode. The way this looks, declaring PIP support, you basically do this in your manifest using the supports PictureInPicture manifest attribute. And then an important thing to remember about this is you should always, if you're supporting PictureInPicture mode, you should add this config changes line. Because what this tells the system is that basically don't reinitialize or relaunch your app during PIP mode transitions. The next thing you want to do is switch to PIP mode basically on user demand. This is via a button. So let's say you have a button in your application the user can press to put your application into PIP mode. To do that, basically implement your on-click listener on your button and call the enter PictureInPicture mode PictureInPicture mode method that's part of the activity. And to that method, it takes a params, which is the picture-in-picture params. The picture-in-picture params are useful because you can actually set actions on top of the picture-in-picture window. So these are buttons that the user can press. And you can also set the aspect ratio. So for example, if your screen is in portrait mode, but you want the picture-in-picture window to be in landscape mode, you can set an aspect ratio to define that it should be in aspect or in landscape mode. Another great thing you can do too, we highly recommend this, is you can switch the picture-in-picture mode when the user hits the home button. You do this by using on-user leave hint. And basically, you call the exact same API here, but once the user hits the home button, this will actually take your app into PIP mode. Again, this is a very nice user interface for media applications or movie applications. And then the last part is hiding non-essential UI. Either the activities and fragments now have on picture-in-picture mode change as methods. And these methods are called when the application either goes in or out of picture-in-picture mode. And before, what I mentioned about hiding the full screen UIs, that's basically hiding everything besides the video viewer, what you're using to actually render the video. And again, you can essentially, if you're using MediaSession in your application, if you have an active MediaSession, you can hide all the controls. And what the MediaSession, or what the PIP will show, is media controls that will be passed into your MediaSession. So another really good reason to use MediaSession. A lot of great resources on getting to learn more about picture-in-picture. I definitely recommend, so the picture-in-picture guide in our developer docs have been updated. It has all this information in it. We also released 2 articles recently. One of my coworkers, Benjamin Baxter, Making Magic Moments with Picture-in-Picture, basically describes the fundamentals of using Picture-in-Picture and the usability around it. And I also did a follow-up on navigation patterns, which talks about using things like the home button to switch the app into Picture-in-Picture mode. And the last one I was going to mention, the last API, again, this isn't exactly an API, but wide aspect ratio screens. So basically, if you don't do the right thing, your application is going to be stuck in 16:9 mode, even though the device screen could be 18:9. What that means is your application will only show up in the blue area on the screen, and the red area will be just rendered black, essentially, by the system. And the reason this is very important for media developers is if you're playing back video, and the user wants to view that video in landscape on their full screen, and they see these bars on the sides, it's going to be a fairly negative user experience, especially since these phones are kind of, these wide aspect ratio phones are kind of premium devices. So the way you want to actually fill in the wide aspect ratio screens, or go beyond the 16:9, basically target API 26 or later. With 26 plus devices, the max aspect ratio is the native aspect ratio of the device. Another thing that you can do, if you can't yet target 26 plus, if you target 24 plus, your apps by default, or your activities by default, are resizable. Resizable, what's used by the system for multi-screen. And basically, if an activity is resizable, it means it supports any aspect ratio, including these widescreen aspect ratios. If you're not targeting 24 plus, you're not targeting 26 plus, you can also go in and make your app resizable. And the last thing you can do is you can actually specify a maximum aspect ratio, but this is the last resort. What you should really do is 1, 2, or 3 above. So making your app resizable, again, this is only for 23 or under target API, because at 24 or above, these are on by default. You can set these manifest attributes, either in your application, and it'll apply to all activities, or you can specify it on the activities themselves. Specifying a max aspect ratio, again, if you're targeting 26 plus, the max aspect ratio is the native aspect ratio of the device. But for 25 or lower, you can use this metadata tag to specify that your app should support these wider aspect ratios. The value 2.1, it's basically 18 divided by 9 is going to be 2, so using 2.1 means that you'll use not only 18 by 9, but even wider screens. The problem with this, the reason that we say you should make your application or make your activities resizable instead of using this, though, is because what happens when there's 2.2 aspect ratio screens? You're going to have to go in and update your application. So ideally, you'd actually support this directly. Before I call Dan up on stage, I'm going to talk really briefly about bringing some updates about Android TV. So at I/O this year, we announced a new Android TV home screen, and we also announced that the Google Assistant was coming to TV. Since then, both have launched. The new Android TV home screen is available on the Nexus Player, and the Google Assistant is available on Android TV devices since Android M, I believe. So integrating Android TV, 4 ways to integrate on Android TV and the Assistant. You can actually integrate content in the Watch Next row. You can create channels and programs. You can implement global search, or you can implement media sessions. Global search provides search to the Assistant on Google TV or Android TV, and the media session provides media controls via the Assistant. I'm not going to go into the technical details about all of these, specifically because we cover a lot of those at Google I/O and the API hasn't changed. But the first way that you can integrate is on the new home screen is the Watch Next row. This row is intended to be used by showing content the user is in the middle of viewing, new content, say a new episode that was released recently, or a next episode in a series. And developers can add content to the Watch Next row. And apps can also allow users to add content manually. So if the user is inside your application browsing content, they can click on a button, ideally click on a button inside of your application and have that content added to the Watch Next row. Apps can also create channels and programs which can be displayed on the home screen. A channel is a row of programs that your app maintains. Applications get one default channel row, so when the application is installed and you populate a channel, that will actually show up automatically on the user's home screen. Applications can have multiple channels, though, and it's up to you to kind of determine how many channels you want and how you configure those. The first way to integrate with the Assistant on Android TV is to make your content searchable using a global search provider. So if the user is either searching for content or wants to play content, so if they use the Google Assistant and say, play Big Buck Bunny, what the Assistant will do is it'll use the global search providers across all the applications and look for that content. If your application has an exact match, it'll actually show up at the top of the list. If your application has multiple matches, it'll actually show up below. So ideally, you can actually find an exact match for the user for these queries. If there's only one application has an exact match, and the user is requested to play the content, that content will actually be automatically played within your app. The user doesn't have to go through the selection process. And the other thing that I mentioned too is voice-based media controls via the Assistant. So if your application supports MediaSession and the user invokes the Google Assistant while your content is playing, they can actually issue transport controls via voice. So play, pause, seek forward, seek backward. So this is very important, another very important reason to definitely consider using the MediaSession when you're building your media applications. So a lot of areas for getting started with the new Android TV home screen and the Assistant on Android TV. So we have several guides in our developer content. We also, for Google I/O, we built a code lab which goes through all the important parts about integrating with the channels and programs. And also recently we released a lean-back sample that shows you how to use the Assistant and tie that in with the Android TV lean-back API. And with that, I'm going to hand off to Dan, who's going to talk about a new, exciting audio API that we have in Android.
All right, I don't have much time, and I'm losing my voice, so please, I apologize for that, but it's great to have you all here. Pro audio is something I'm very passionate about. So first of all, we added a new Pro Audio API to Android O, and we already had OpenSLES, but we wanted to do something that was easier to use and easier to improve. Now, all the audio APIs end up going through this framework, but since making huge changes there could potentially break lots of code, AudioFocus has a new service where we can do some pretty radical things and get some performance enhancements. And actually, if you're running the developer preview on a Pixel or Pixel 2 device, you actually can get really reduced latency thanks to this framework. So very, very cool. Now, AudioFocus uses the concept of streams, in this case, flowing from the mic to the app and then back to headphones. And these audio streams are really easy to create. We've made this API much more straightforward using this builder design pattern. So basically, you can set this up and then make multiple streams, which is pretty slick. In this code, we have the AUdio create stream builder, which gets you a default stream, which is probably a stereo output stream. And here's how you request specific values for direction and for format. And once you set up a stream, you call OpenStream on the builder. Pretty straightforward. And now if you don't set things like sample rate and format, you'll then have to query them. And finally, you'll get the frames per burst from the audio stream to get the optimal read and write size. Okay, now let's stop for a moment, because I know your eyes are all glazing over and you're like, all right, this is only in the O release. How is this really helpful to me? But we've actually released a library to help, and this is really what I'm excited about. So this is a C++ API. First of all, it's called Oboe, and it works almost identical to AUdio. And it works on both old and new versions of Android. So on old versions of Android, it's going to end up calling into OpenSLES. And this really makes it easier to write high-performance, low-latency audio applications on all Android devices. So here is what AUdio looks like, and here is what Oboe looks like for the exact same code. So as you can see here, once you've used one, it is really easy to use the other. Now, in AUdio and Oboe, a buffer refers to an array of these kind of bursts of audio data. And this data is written in these bursts to the DAC. Now, when you look at this diagram, the app has generated 2 bursts of data, and the first burst will be written. Now, as you might expect, you can start and pause or stop your stream all with these synchronous calls. And honestly, for most use cases, that is optimal. But we do have a function for synchronizing if needed. And the real question is, how do we get data in and out of these streams? So let's take a very simple use case here. For apps that don't need super low latency, you can use blocking writes like this here in a loop. So basically, the blocking write function returns after either the number of frames is written or an error happens. Now, the blocking write can time out, so we might only get part of the frames written, so we need to make sure we're handling this case. And when you need lower latency, you can actually you need a higher priority thread to do your audio processing, or perhaps even one that's scheduled with sched FIFO. And so when you write this callback function, Oboe will pass you the stream parameter, any data you need, the audio data buffer, and the number of frames, and then you can render your audio right into the audio buffer on the high priority thread, and you set this callback up in the builder. So the question is, how do you combine multiple streams? Such as if you're taking 2 or more input streams and sending them to an output. And we recommend using one output stream as the master callback, and then you do the callback from the master stream. Now, since the current Oboe implementation does not yet support audio input, I've switched back to the AUdio API here. And in this simple example, we're just passing data from input to output. We can read the input from the input stream with a 0 timeout to do a non-blocking read, and that goes right into the output buffer. And it may take a couple of calls for these 2 streams to synchronize. There we are. That's what I wanted. All right. So again, that's how you read from the input to output stream. Finally, let's talk about how you would do dynamic latency tuning. And this is really important when you're doing these very low latency audio applications. So looking back at that previous diagram, we have these 2 bursts ready to be consumed by the DAC. And if we're glitching because of preemption, we may want to add another burst to our render. Oh, can you pass me the other clicker? We can detect overruns or underruns we've had on our output stream by calling getXRunCount. And if it's changed since the last time you checked, you've got a glitch. So you can just add another burst to your buffer size. So once again, here's a basic Oboe program using a blocking write. Very straightforward. And here's the equivalent code you would need to do that in OpenSLES. And this is only a partial set of code. So we really have simplified what it takes to do these kind of professional low latency audio applications. And that's all you have from me. So thank you so much for coming. And again, I'm sorry my voice is a little scratchy.